Okay, here's our newest question. And if you can deal with fractions well, then you can get these two terms with the variable together by figuring out a least common denominator and keeping with the fractions for a while. However, if you don't like dealing with fractions, then we could get a least common denominator, get the least common denominator. 5 will go into both of those. That's a factor, not a multiple. And whether you look along diagonals, I've stopped with my dividing because the only thing that goes into 4 and 3 is 1. If I look along the diagonals, 20 times 3 is 60, and so is 15 times 4. I also get my 60 from looking along the left side and both of the bottom. Well, I'm going to multiply both sides by 60. That's going to get rid of fractions, at least for a while. It might be the very last step where some fractions might come back in, but in the meantime, I'm not going to have to deal with them. On this side, 60 divided by 20 is 3. On this side, I have to distribute before I can reduce. 60 times 7 is 420. And then 60 times n over 15, the 15 goes into 60 4 times. So we've got like terms that are on opposite sides, none of them that are on the same side. This doesn't have n, and so these cannot be combined. We want to get together 3n and minus 4n. But negative 4 is less than 3. I'll do the opposite of subtracting 4n, add 4n to both sides, and get 7n equals 420. Dividing both sides by 7, I would have n equals 60. 60 over 20 is 3. 60 over 15 is 4. 7 minus 4 does equal 3. So when I type in an answer of n equals 60, it should accept it, no problems. And here we go. And it takes it. Okay, so moving on.